Alright, welcome to Bright Engineering once again. Today we'll be solving a question on electromagnetism, and the question reads: a rectangular shaped core is made of steel plates 15 millimeters by 120 millimeters cross section. The mean length of the magnetic plate is 18 centimeters. The exciting coil has 300 turns with a current of 0.7 amperes flowing through it. Calculate A, the magnetomotive force, B, flux density, C, reluctance, D, magnetic flux, right? So in the question we are given the relative permeability of the plate, which was 940, then the area, cross-sectional area, 15 millimeters by 120 millimeters, which would give us 300 millimeters, and we can further on expand or convert the meters to its equivalent, which is 10 power minus 6, right? Meters squared. Then the length is 18 centimeters, and that will also be 18 times 10 power minus 2 meters, with the number of times being 300 and current of 0.7 A, right? So now we are being asked to find the magnetomotive force. So A, magnetomotive force, MMF or F, which is equal to the number of turns times current. So our number of turns here is 300 times current 0.7, and this should give us 210 amperes or ampere turns, depending on the unit we want to choose or use. Now would look for flux density. B, we should find flux density, right? Flux density B. Now we know that absolute permeability is equal to flux density on field strength, right? And this can further on be expanded as mu naught mu r is equal to B on H. Now from the formula H is equal to FL, we can find the value for H using the F from the previous solution in A, and with H being found and we knowing this to be a constant and this being given in the question, we can find the flux density. So H therefore is equal to 210 on the length, which is 18 times 10 power minus 2, and this is giving us 1166.67 ampere per meters, right? Now mu naught is constant 4 pi times 10 power negative 7 Henry per meters, and mu r was given in the question 940, relative permeability. So now multiplying this to 4 pi times 10 power negative 7 times 940 would then be equal to B on H, and we found H to be 1166.67, right? This 4 pi times 10 power negative 7 times 940 then gives us 1.1812 times 10 power negative 3, and this will be equal to B on 166.67. B therefore becomes 1.1812 times 10 power negative 3 times 116.67. B therefore becomes 1.378 Tesla or T as the unit. Now moving on to C, we are supposed to find the reluctance. So now our reluctance S can be said to be the force on the flux, right? And we've pre-calculated for the force, and that's 210 on flux. So flux has not been given in the question. That means we need to find flux, and we know that. All right, so I want to find flux, but I realize I can also use another formula to find the reluctance without necessarily needing to find flux. So if reluctance is equal to the length divided by the product of absolute permeability by area, we can use the straight ahead without finding anything else, because all these values have been given in the question, with length being 18 times 10 power minus 2. Then absolute permeability, which we know will be equal to mu naught mu r, then multiply A. So we'd have 18 times 10 power minus 2 all over 4 pi times 10 power minus 7 times 940 times our area, which is 300 times 10 power minus 6. And this would give us an answer of 0.508 times 10 power 6 ampere per Webers. All right, so to the last one, D, you have to find the magnetic flux. So now we can say S is equal to F on flux, and we've already calculated for reluctance, right? So reluctance is equal to the force on the flux, and against change of subjects, we can have flux to be equal to the force on reluctance. Therefore, flux is equal to the force, which is 210 divided by 0.508 times 10 power 6, and flux would be equal to 0.413 times 10 power negative 3 Webers. All right, this brings us to the end of our solution, and I would encourage you to like, share, and subscribe.